In the last topic, what we had done is we had really begun our deeper explorations of Faraday's law. And in particular, we discussed both Faraday's and Lenz's laws and began to apply those to the topic of circuits. The basic concepts were as follows. First, we had Faraday's law, which is one of Maxwell's key equations. And you'll notice it tells us that the line integral of E around any loop is not zero, which is what we had been expecting previously and what we had done in previous portions of the course, but has this additional term which only begins to appear when we are in a not steady state situation, a situation where there are changes going on, in particular changes to the magnetic field. And that line integral of the electric field then is related to a time derivative of magnetic flux. The only extra piece we need to understand here is the presence of this minus sign. That minus sign actually is directly related to what's known as Lenz's law, or what I like to call the so-called no free lunch law. That minus sign basically is embedded in the equation in such a way that it ensures that the EMFs that we calculate with this line integral are always such that they give or would give currents, if currents could flow in the situation, always which would oppose any change in magnetic flux, whether mechanically by creating currents that create forces that resist any mechanical changes, motion of wires through the magnetic field that might be changing the magnetic flux, and or magnetically, where the flux induced by such a flowing current would in fact also tend to be in the direction opposing any change in magnetic flux.